Greetings, friends. My name is John Gabriel, and this is the new Calculus channel. Welcome once again. So, in this video today, I shall continue with Euclid's Elements, proposition 2 through to 10. And there are some interesting details I'd like to share with you. And let's get right to it. So, okay, so in proposition 2, we see use of the word tichonda, okay, and that means by chance or random. And then as one of my subscribers from Australia mentioned, in 2.4 we see the expression os etichen, okay, which as he correctly mentioned, means as it happened. And I think being good at Greek as he is, he said that is mentioned in the subjunctive mood, and also that when ean and I is used, they are both used differently. So, for example, epsilon iota means a strict F, but ean means let it be, ean means if it may be. And then, of course, one word that I've always had a problem, especially in my youth, trying to understand is this word gar, and I think it means let, but I'm not sure of that. Perhaps some more knowledgeable Greek person can write in the comment section and tell us what this word means, or perhaps the same person from Australia who pointed these things out. So in any case, without further ado, let's begin on proposition 2. But wait, there's one more announcement. This is the interesting part. Now, many years ago, I came across this wonderful site, by the way. And if you like riders, then this site is for you. I trust all of you know what a rider is. It's basically a geometric theorem or a geometric statement that needs to be proved. And those were my all-time favorite when I was at school. I loved proving geometric theorems. In fact, I could do nothing but that all day. That was so fascinating to me. And I'll tell you that this site here has much more than anything you can find in Euclid's Elements about circular geometry, triangles, anything that might be derived out of Euclid's Elements is magnified here many times. And it's a free site. It's a wonderful site. I really think that if you're at school and you want to learn how to complete proofs, this is where you should go. And it will help you in every other respect. So anyway, let's continue with proposition 2. So what that says is that any 2 points that you see here taken at random and joined by the shortest distance, this blue line, will fall inside a circle. And that's pretty obvious, isn't it? Why? Because the arc on which said secant rests is much longer. So any line that is not this blue line will be much longer. And since a secant by definition lies inside a circle, I frankly fail to see why there would be any need to prove this. But if you want to look at the proof, it's available in the original text. So one only needs to consider a secant by definition. And note that it's subtended on an arc which is longer. So there's nothing really to prove. It follows from the 5 requirements, because secants are used in my prologue, which discusses the 5 requirements. Proposition 3 says if any straight line through the center cuts another straight line not through the center in half, then the lines meet at right angles. So again, this is proved in the prologue, because without this, we don't have all right angles are equal, and we don't have parallel lines. So this is all it says. It says that if this blue line is cut in half, then then the angle will be 90 degrees, right? Does that make sense? Can you see that? Okay. So any line from the center bisects a secant at right angles if the bisection if the bisection produces two equal parts. In other words, this side of the chord or secant and this side. Then we have proposition 4. This is a more interesting proposition, but still unremarkable in my opinion, or particularly useful in any sense whatsoever. But what it says is that if any two straight lines, like you see here, equal straight lines, okay, intersect each other not through the center, they cannot cut each other in half. They don't have to be equal, but if they're equal, you have the symmetry here, where this part of each line is equal and the blue part of each line is equal. But as you can see, it doesn't matter what you do here. These lines can never intersect each other in half, okay? And of course, that goes by symmetry of the circle, because diameters cut each other in half, and any other line can only be cut in half by a diameter, right? All right, so if you have a diameter, then any other line on the circle can only be cut in half if the intersection is at right angles. Okay, and the converse also applies. Proposition 5 says if two circles cut one another, they will not have the same center. Okay, so that's pretty obvious, because I mean, it goes by the definition of the circle. So if we have to, let's say, let them intersect there, and if it's just in one point, you'll notice that the circles will have the same line pass through their diameters, and so of course, if they have the same center, they'll be the same circle or another circle of the same size. Again, I don't find that to be particularly interesting or remarkable. Proposition 6 says that if two circles touch one another, then they will not have the same center, and I've already discussed that. Proposition 7 and 8 are more or less the same, with a slight difference. And what they basically tell us is that if we have a point outside the circle and we draw straight lines to the opposite ends of the circle, then one of these straight lines will be the longest, the longest out of all the straight lines. And of course, one of them will be the shortest. But the longest one will obviously be the one passing through the center of the circle. And why is that so? Because once inside the circle, the straight lines with a shorter section occur. So, for example, if we have a tangent there, all those, there the part in the circle would be 0. Then suddenly it starts becoming longer and longer and longer until it passes through the diameter, right? And of course, the lines become shorter as D becomes this tangent line. The point D becomes tangent to the circle on either side, by the way, right? On either side. Then proposition 9 and 10. 9 is unremarkable. 10 says a circle does not cut another circle at more than 2 points. So that's also, I guess, worth mentioning. If the circles are tangential to each other, then they cut each other at 1 point. So it's either like this, or as I showed you in this one here, where the one circle is like that inside. So that's at 1 point, or at 1 point like this, okay? And then if the circles meet each other in every point, then they are the same circle, right? They're the same circle. So they cut it innumerably many points. Otherwise, part of each circle will lie in the enclosed area of the other, like so, meaning that they'll each have an arc that joins the point of intersection, which is only possible if they cut at 2 points, right? And that's pretty much it for proposition 2 through to 10. We'll try to get back to more videos on book 3 and try to finish the propositions in book 3. And then I'll probably give this a break for some time and address some other videos at some future time. So if you've enjoyed this, very good. If not, well, then maybe you'll enjoy the next video. I'm John Gabriel. This is a New Calculus channel. Till next time, goodbye, folks.